with Willamette Industries, Geldwin, and then also within his family's construction business. He's currently the VP of the Cut to Length Systems and Chief Forester for Miller Timber Services. Preston, as I said, they're both Oregon State alumni. He's been with Miller Timber Services since 2018, and he was started with this company while he was completing his graduate studies. And he ended up with an MS in Sustainable Forest Management, along with an MBA in 2019. And he specializes in cut-to-length operations across the western U.S., and he focuses on analytics, research and development, and functions as their director of university outreach. So with that, Matt and Preston, take it away.
Thank you for that warm introduction. Appreciate that. Let's see, I'll grab a clicker here. So good afternoon. Mattioda, Chief Forester, Miller Timber Services. We are based out of Oregon. This is the project in particular we're going to be talking about here out of Monarch Pass, just above Salida. So a little bit on us here, real quick. Who are we? We're based out of Philomath, Oregon, but we operate everywhere. We have a base of operations in California and in northern Idaho as well. We're the largest operator of cut-to-length harvesting equipment in North America. We currently could, if we put everything together, we keep some spares around, but we could put together 18 operational teams if we wanted to. We work primarily in Washington, Oregon, California, Idaho, Colorado, and now Arizona. Although we have done some work here in New Mexico before, down out of Rio Doso. So our company is pretty diverse. We're a full cycle forestry services company, meaning we have reforestation crews. Our company, we don't own land, but our company plants about 7 million seedlings a year. We also have pre-commercial thinning and hand crews. Our cut-length operations, associated trucking that goes with those cut-length operations, and we also staff wildland firefighting crews, and this year we could staff 8 to 20-person wildland firefighting crews that have national and state contracts and work all over the country. So just because we're based out of Oregon doesn't mean we don't work other places. We actually have California employees, Colorado employees now, and we have some employees transferring down to Arizona. So a little bit more about us, the QR code there if you'd like to. So we're going to talk about this project. Why this project? How did this project come into being a little bit? And then the partners in this project. Then we'll talk about the challenges of this particular project. It's definitely challenging. I'll let you read all the things on there. Kind of keep moving here. Preston's going to come up and he's going to talk about preliminary research. We've been working with the Rocky Mountain Research Station and doing some preliminary research on the effects of this system and trying to better ourselves. We like to consider ourselves foresters with tools, and as such, we always are striving to improve our processes to deliver a better final product for society. So important to us to learn and then take those learnings and actually implement on the ground. It's a continuous process for us. And then we'll talk about some operational takeaways. Preston will cover that from this particular project. So we'll kind of jump into this project here a little bit. Where is it at? In relation to the mountain pine beetle and spruce beetle epidemics there where the star's at, that's the top of Monarch Pass there in Colorado. So this was brought about because of a lot of spruce mortality, 80% plus, and the threats of wildfire and what the effects would be on the watershed. Also, this particular area is very steep, was not suitable for traditional logging equipment. We do work on flat, easy ground too, but this particular site doesn't have that. So there's a picture of it here. There's also a lot of infrastructure up there at the top of the pass. That's Highway 50 in the background. Ski Monarch is there in the back. It's really faint. You can barely see it. There's a big WAPA power line that cuts right through the middle of the unit. There's an Excel Energy power line at the bottom of the hill. There's a gondola ride just to the left of that picture over ways. There is a huge array of communications towers at the top of the mountain. There's also a visitor center and a restaurant and all kinds, there's a lot of infrastructure, a campground at the bottom of the hill, and it's the headwaters of the South Fork of the Arkansas. So a lot of values at risk right at the top of the Continental Divide. So it's also a great place for a fuel break. If something was to spill over from the other side off the Gunnison, the hope is that we could, maybe hold this thing here. Here is a map of our project area. We used all existing roads and infrastructure. We did not construct any new roads or any new temp roads into this. Everything was existing roads, and that presents some challenges even in and of itself. Because there are limited access to large portions of this particular unit. If you look on the lower right-hand side down there, you see there's a dotted line on the edge of the project boundary and a ridge. That's a very large ridge, and we'll see a picture of it in a minute. There's no access. There's a mid-slope road that comes partway through this unit, and then that transitions into a cultural resource site that cuts across the hill. So there's large portions of the area that do not have any traditional access. And as such, typically this would have been considered not something that would be viable. And the way the ground rolls, even that mid-slope road, the stuff below the mid-slope road really isn't set up very well for traditional cable yarding systems. And then above the road, it definitely would not be. So in total, we did 468 acres over the past 2 summers. Our machines keep track of the trees they cut and the volume they produce. So that translated into 72,880 trees cut off that 468 acres, or about 156 trees per acre removed, translating into 22,323 cubic meters of wood. Now, I know we talked the CCF to cubic meter ratio. We throw all these numbers around. It's like a little over 35 cubic feet per cubic meter for those that want to do the conversion. Our machines think in metric, so we think in metric. So I'm sorry for throwing it out there, but that's how we gauge ourselves. So they got this project idea. Next is, if they got funding to do some work, are they going to find somebody to do it? And if you build it, will they actually come? It's like Field of Dreams. If we put this project together and spend this effort, spend this energy, is someone going to show up and do it? Which is a big concern because, the Forest Service has limited staff and budgets and other priorities. So there was some discussion that they had internally about this. But ultimately, it takes leadership. And good leadership at the local forest level decided that, they had talked to a gentleman who's now retired from the Forest Service. And he was a specialist in logging systems, and they consulted with him, and they said, well, I know these folks out in Oregon, they do work, and they could get on something like that. And so we went and actually took a preliminary look at this too to see if it was possible before they put a whole lot of effort into it. They did, and they figured out, well, how are they going to get funding for it? Well, Alex Redney from the local district office, he's a silviculturist, took this up, said, we need to do this too. And he went to the regional office and said, okay, if we want to do this, and they said, well, if you find some money, we'll find some matching money. And Jim Pitts, the local district ranger, they all got on board with this and said, yeah, let's go try this thing. So they went there, laid it out, and got some money from some partners, key collaborators who we'll show in a minute. Came back to the regional office, said, okay, we got some money, throw us some more money, and let's make this thing happen. So here's all the partners in this to make this project work. Lots of people, lots of interest, a lot of values at risk here from, that I'd mentioned, all the infrastructure, water, resources, and then the fact that in a lot of these mountainous areas, some of the easy ground, or a lot of it, has been picked over and done. So now we're moving into areas that are traditionally harder. So I think a lot of folks here on this list also wanted to learn and see, what can be done? What can we do here? Because helicopter logging is very, very expensive and very limited as to when we can do it. So is there a better way? There's the ridge that was on the map. So everything on the left-hand side of that ridge, you see a little forwarder down there in the bottom. Left-hand side of the ridge, we did all the way down to the bottom of that valley down there. That entire ridge, about out to the end there where you see it. We did everything there, and it wraps toward me to the left-hand side and wraps around Highway 50 and then spills up above Highway 50 as well. So quite steep, quite large area. So it's 1,232 miles from our main office in Philomath to here. So for us, it's expanding our operational area. We are used to working away from home. We've got systems in place and operators and a procedure for doing this. So for us, this was a first stab at doing some stuff here in Colorado. Little risk on our part. But then also, a lot of challenges here because we're starting at tree line and working down or working mid-slope up to tree line and down, and we've got high mortality, trees that naturally just have a weak root holding ability because we tether on these trees, a weak root holding ability, and they've been dead for a couple years. Plus the fact that, I live at 300 feet elevation, and right here is almost 12,000 feet, so it's a little hard for me at first to get up there and breathe. And it's also hard on the equipment. Equipment operates, and the power band is completely different at that elevation than it is at lower elevation. So a lot of learning and challenges there too, is what it can do, what it can't do, how much power loss is there at this high elevation. So a lot of things we had to overcome. Also, we have a tethering system on these machines that we tether on either a piece of equipment or trees or multiple trees, and it's got about 1,200 feet of line on it. But we had slopes that were well over 1,500 feet between areas where we could actually land the wood. So how do you accomplish that? So we had to do a little bit of learning to figure out how can we go above and beyond what the machines are normally capable of doing. And 1,500 feet plus of elevational gain. Then we had the supply chain. We've been talking about supply chain a little bit this morning here, right? And a lack of infrastructure, trucking ability, the type of trucks to haul short logs, because we make short logs with cut to length equipment. What do you do with it? So we found some partners over in Montrose Forest Products and also with Blanca Forest Products and a few other people as well. We kind of spread the love around to everybody here, delivering wood to different locations, trying to support the industry in Colorado as a whole. So we did spread wood around, which we feel is important as an organization to do, to help, rising tide lifts all boats here. Then there's snow, the truck availability, configuration. So we actually brought trucks in from out of the area because there's no trucks in the area that could handle this particular application. And then we have specialized machines, and specialized machines take specialized maintenance and specialized maintenance technicians. So we had to bring in folks whenever we had issues to work on them. We have a very rigorous maintenance program on our machines. We time life out components. We treat them just kind of like aircraft in that sense. We don't wait for things to break. We do a lot of PM work. It's how we operate. So getting folks there, uptime is very important to us, so that's how we operate. With that, I will let Preston talk about some of the research effects from us doing this work here on the mountain and what we've learned.
Okay, thanks Matt, and thanks everyone for being here. We'll try and kind of move through this quick. I got some high-level ideas that I think would be really great to share. But I think this, to kind of preface this research conversation is important because particularly for what we do, we've been running cut-to-length equipment since the 90s, but there's, since 94, but there's overall a lack of institutional knowledge around some of the impacts of these systems and what they're doing. Particularly, that's a concern for federal land bases. So that's kind of the motivation behind why we try and collaborate and partner with different research institutions to do this work. So my name is not Chuck Rhodes, but if you know Chuck, you're familiar with his research background from an operational focus. So we partnered with Chuck to do this work in this project. So I'm talking about it, but really Chuck is the guy that did the work with him and his research team listed there. So we've talked about kind of what this project is, and really for Chuck and his research perspective, this was a pilot project, and like I said, there's a lack of institutional knowledge, and so really trying to fill that need and that void to get this information and this data from real-world operations. It's always beneficial and better if you can get something real. So trying to fill that void, and a couple of shameless plugs here. There was some news articles done from the local area, if you want to peruse those. The basic premise of this was he wanted to look at some of the environmental impacts as it relates to sediment yield and transport and deposition. So we started fence installation of June of 2021. In the summer of 2020, a lot of preliminary data was taken, both on untreated and treated portions of these acres. And then we really got into fence installation for the sediment yields this summer, and then data collection as well. So I'm going to focus on some of the preliminary results that we got out of those sediment fences. And I just kind of keep in mind of the timeline here. So installed in June 21, okay? And not long after that, there was a pretty good monsoonal rain event, and so that provided a nice little shot to the system to see how these trails responded. And we're talking short periods of time after active operations, right, in the grand scheme of things. Within a year or two, or sometimes within the same year that these operations happen. So fresh operations and impacts on the ground from what we're doing, and then a nice monsoonal shot of rain here to really test out what happens. And I guess I'll preface this as well. When we're doing our active operations, we're intentionally putting a lot of slash material back into the corridor, and we're walking on that in front of us. So we're essentially looking at how effective is that material in either reducing or controlling sediment yield and transportation and deposition, and then how much, right? How much do you need? What's effective? What's not effective? But with the main cornerstone being that we process that material into the trail in front of us as we work. So monsoonal rain here, we can see the graph there, the 20th, you see that nice episode of rain, and this was equivalent to just over 2 inches an hour, which is quite an intensity, especially when we talk about the slopes on this project, the high elevation, the exposure, all that stuff. And so what happened, right? What did we see? Well, we've got some data here from these silt fences, and you can see a pretty stark difference in some of the bare versus slash covered corridors. However, if you exclude number 4 and number 9 there, and you look at some of the other ones, they're not that far off from the bare trails to the slash covered trails. Now, that's not to say that, yeah, we can just run around on bare mineral soil all the time and not have any impacts. That's not what we're saying, but it's helpful to have that comparison as we start to explore and look at how much of this slash material and this do we need, and what kind of a difference does it make. Okay, so really just highlighting, okay, high intensity rainstorm event, this is a sediment yield that we saw, okay. And then just to zoom in on that a little bit. And so we saw those corridors that had some heavy sediment deposition, but that wasn't everywhere. Okay, some of these looked okay. That one was one that was bare. This is one that had heavy slash. So not to say that there's no impact, because obviously we've got deposition in that trail with not as much slash. But to get an idea of the spectrum, right? What are we seeing? What are these impacts? Okay, a couple more. Again, these are taken July 30th of this year, and so after that high intensity rainfall event, and really not much delivery there. I mean, that very well could have been critters walking by and kicking stuff into the fence for all we know. So not much deposition there, but like Matt said, we're always trying to look at our systems and look at how they impact the ground, and what are we learning from that? How can we change what we're doing to get a better product? Because we know that there are legitimate concerns about operating this equipment on steep slopes because of the lack of knowledge here. So this is another look at those areas, at that fence that had that higher deposition. This is a trail that we were on. You can see a lack of material in there, and there's some stuff that's mulched and mixed into the trail, but you don't really have a lot of good surface cover to reduce that rainfall intensity as it comes down. Okay, but it's always important to look at this in context, right? So this is one method of treating a landscape, and I think anybody would agree that letting a wildfire go through an area is another method of treating a landscape. It has an impact. So we're looking at the trade-offs between these two impacts, and it was interesting to see, somebody earlier mentioned some of the debris flows that the state of Colorado has experienced along I believe it's the I-70 corridor. And I believe this was the pictures on the right were from one of those debris flows. So similar rainfall intensities, but yet two very, very different results, right? Proactive management approach on the left, yes, you get some impact, maybe some negative impact due to that sediment deposition, but I would argue not quite the impact and the severity from a devastating wildfire going through before and treating a landscape, and then having that same landscape being subject to a heavy monsoonal rain event like that. So just trying to put this into context, right? How do the decisions that we make about active management compared to other decisions that might get made out of our control. And that's a big question, right? That's why we're all here, right? This is a big concept, big idea. It takes big solutions to solve these problems. But you know, we've already got tools in place. So some operational takeaways from what both Matt covered and what we looked at from the research component. This is still complex, challenging work. And like we said, we've been doing the cut-to-length harvesting system since '94, and we're always continuing to learn and grow about what we do. We're certainly not doing it the same way that we did it 27 years ago in '94, and for that matter, we really didn't finish the Colorado project the same way that we started it, based on some of the research work that we were doing with Dr. Rhodes. And so that naturally creates an evolution of practices, which lead to things like BMPs, right? We know what we need to do. We've seen the results, whether it be research results or just on the ground, you know, observational results. And so that opens up different possibilities. I guess one thing we have in there is merchandising as well. And so when we see some of these impacts, we have a lot of options and things we can do to change what we're doing, to mitigate or change some of these impacts. And merchandising, believe it or not, is one of those ways. How do we process this material? How do we go about the operational layout and strategic structuring of how we do our work in order to mitigate some concerns and highlight some other benefits that we really want to make sure are in place? And that opens up possibilities, right? The more we learn and the more we experience these things, it brings into light other projects that before maybe we didn't really think were possible. But due to some of the things that we learn on projects like this, we can wrap up other projects into the scope of what we're capable of doing and be able to treat more acres on different landscapes to effective levels. That slide that had all those people on there, certainly a lot of heavy lifting to be done there. And so this partner development is huge, critically important for what we do as a private industry, but also looking at the greater need of these landscapes and these communities. So that partner development is critically important. And we talked about, you know, wildfire mitigation, right? The treated landscapes, your ability to fight that in a much more direct fashion because you have those breaks set up is much different than just sitting back and watching something rip through a whole drainage structure. The fuel loading reduction data, Matt talked about the the cubic meters removed and the cut trees per acre. That's all fuel, right? And most of that was dead material. So that fuel loading getting off the landscape is huge. And then also breaking up the structure of the fuels that are still there, right? Because of those corridors, that is creating a different type of fuel loading because of that material on the ground and in the ground, but it's also breaking up canopy connectivity to help these mitigation efforts as well. And you know, the idea is, how do we get more of this, right? Increasing the pace and scale of these operations. Well, you know, I think we have the keys and the tools that we need. We just have to get the right people together, right? We've already got these tools. We know this equipment and these systems and what they're capable of, but we're learning more and more through these research projects and these pilot projects. But you know, we don't necessarily have to wait. You know, we're a pretty aggressive company in how we go after projects and just the nature of what we do. So we're not typically ones to sit idly by. So, but just a few thoughts on what our experiences were from Colorado. I wish we had more time to talk about this because it's a really cool project, but nonetheless, that's what we have. So I think we'll turn it back over to Rich here.
Thank you, Matt and Preston. Some pretty interesting project up there. I was talking to Preston before the presentation, and my older son and his girlfriend ski up at that Monarch ski area there, and Preston was wondering what they thought about it, and it was a big concern to a lot of the locals there. I can tell you that whole Monarch ski area kind of getting kind of infested by the beetles there, and I think a lot of the people are kind of breathing a sigh of relief, because if a fire got in there, it would be just devastating. But anyway, great presentation. Next up, I've met Brian before virtually, and this is the first time I've met him in person. So Brian O'Connor's going to be giving our second presentation of the panel, and he's titled it Electric Forest, New Age in Forest Restoration Operations with Forestry Machines, battery powered using air curtain burners. So we're very lucky to have Brian O'Connor. He's the president and chief designer of Air Burners Incorporated, and that's a company he founded 24 years ago and specializes in environmentally sound biomass waste reduction and energy conversion technologies. Just a little more background. Brian is an honors graduate of State University of New York, and for more than 30 years has worked on technologies that protect the environment, reduce waste, and develop green renewable energy. So in addition to what he's done with Air Burners team efforts, he's also working with the U.S. Forest Service to develop a portable biochar unit. I know that's a big discussion item today with biochar, and so that'll be kind of interesting. I don't think he's covering that in his presentation, but he's got some further information on that. And anyway, he's going to be discussing his current unique portable biomass energy system. So please welcome Brian O'Connor. The pointer's right here.
Top one, bottom one?
Yep. Advance. Back up, and then the top one is your pointer.
Oh, okay, great. Well, thank you, Rich, I appreciate it. So, anyhow, as Rich already said, we've been around for 24 years now, and you can see by this cute little map, this little green flags there kind of indicate where we have a lot of machines, in those sort of areas. So, we're on every continent except Antarctica. Unfortunately, the polar bears don't make too much vegetative waste, and so we haven't been able to sell any machines in that area. I don't know how many of you are familiar with an air curtain burner, but the purpose of an air curtain burner is to eliminate. I mean, we're sitting here talking about using and uses, and we're going to get to that in a minute, but if we can't use it, we got to get rid of it. And so our machines are designed to eliminate wood and vegetative waste. At their core, they're a pollution control device. We use air curtain technology to trap the smoke particles and reburn it. Basically, it works as a secondary burn chamber. Oops, wrong way. And so why do we want to eliminate this? Well, so one of the things that we have to look at as a company is the wood and vegetative waste situation worldwide. And I've written a couple of papers on this. I call it the forgotten waste because I would argue that we're basically at almost a crisis situation, including in America. As an example, if you look at that pie chart, we collect roughly 50 million tons of vegetative waste curbside in America. And if we put all of our recycling, biomass energy, wood chips, everything together, we're not even recycling half of that. So, and that's here in the United States. But most importantly, that doesn't include tree mortality, state and national parks, or agriculture, the waste from that. Now, some of you are from California, you're probably very familiar with Sierra Nevadas, and the Forest Service did a count there, found something like, I think it was 106 million dead and standing trees. That's somewhere between 700 and 800 million tons of vegetative waste. Sooner or later we got to do something with it, or Mother Nature will do something with it. So if we can reuse it, that's terrific. If we can't, we should probably get rid of it and replant. So anyhow, this is kind of what the machines look like if you haven't seen them. I didn't plan to talk about biochar. I didn't know it was going to be such an exciting topic here, but I'll touch on it in a minute. But so we make little towable products like in the top left-hand corner, we call it the Burn Boss, that you can take through. That's usually for wildfire mitigation, gets down logging roads easily, and as you can see in that shot, vineyards, state parks, that sort of thing. We have some that, to make mobility a little bit better, we have boxes that meet the ANSI spec for roll-off trucks, so you can move them around, and then our standard fire boxes you know, kind of look like the ones in the middle there. So you might ask, do they work? Well, yeah, I guess we've been around for 24 years, so they do. But we have submitted to all kinds of testing all over the world with a variety of air quality agencies. In fact, we were really fortunate to be asked by the US EPA to become a cooperative research and development partner. There's only been about 40 companies in the world that have ever been offered that opportunity. And we were their partner for about 7 years, and it was a great opportunity to learn a lot of things. We have a couple of creative partnerships now with the U.S. Forest Service. We have one where we're doing a new biochar machine, and like I said, I'll touch on that in just a minute. But today, we're kind of focusing on this, the idea of like the biomass campus, for instance. And about 12 years ago, I wrote a paper called The Electric Forest. And at the core of it was basically a biomass, power generating machine. And the idea being that you could surround it with equipment and power it all up and pull diesel out of the forest and that sort of thing. Well, we brought that to reality, but unfortunately, all the equipment and battery-powered machines and things weren't quite ready. So we were a little bit ahead of time. So today, we have this system, which we call the PG Firebox. We sell mostly to cities and towns to put in their landfills to get rid of their vegetative waste. As many of you might know, our cities and towns now in many states have passed legislation that says no more green waste into the landfills against the law. So what's a person to do? So this machine sells for about $865,000. It's about the same price as a grinder, but this will eliminate the material. In addition to that, it makes electricity, connects to the grid, and you get, what are they called? You get landfill diversion credits. And I don't know much about landfill diversion credits, but I guess they're worth a fair bit of money. So now cities and towns, I say, are using the landfill diversion credits to be able to justify this. Plus, it's a good way to get rid of vegetative waste. The unit has 3 components. There's a firebox module. There's a power module. In there is an organic Rankine cycle waste heat generator. So we capture the heat, we make the electricity in there, and there's a little control room at the far end of that. And then on the far right of the picture there, you'll see a cooling module. And the cooling module is sort of optional. It depends on if you've got like a river or a stream or something like that. It's for recondensing the working fluid, basically. So if you're not familiar with biomass incineration, you might ask, with all this waste, why isn't it our #1 source of elimination? Well, the problem is it's really, really expensive, and this is the reason. If you have whole logs and you need to get rid of these, and branches and root balls and all this kind of stuff that there's no other use for, you first have to submit it to a whole log grinder. Whole log grinders can burn anywhere from 50 to 100 gallons of diesel fuel an hour. Right? And then, unfortunately, although they're trying to design some now, there are no biomass incinerators that can accept the grindings from a whole log grinder. So you have to then submit them to a secondary chipping. So now you're going to burn up some more diesel fuel. And now, the real irony is that you've taken a perfectly burnable product and you've made it non-burnable because, as most of you know, chips just smolder, they don't burn. So now you have to add between 10 and 20% supplementary fuel, usually natural gas, to be able to burn this stuff. And so, that's the reason that the biomass incinerators, because it's now working at 25 cents a kilowatt or so, I mean, it's huge. It's, 5, 10, even 15 times the price of hydro. It's 5 times the price of solar. They've come down. Biomass incineration hasn't, except for us. So with our system, you take the tree, throw it in the firebox, or a root ball, for instance. There's no criteria for the wood for our machine. There is in typical biomass incinerators. You can't, decayed wood, things like that. You can't submit that to those, but you can with ours. So it's a very simple process. But one of the important components here is that it's not a permanent system. It's movable. So there's no processing required, and it's a movable system. That's important because of what's called the waste travel zone. So for most of the biomass incinerators to work, you have about a 50-mile radius. And if you travel more than 50 miles to bring your waste to the incinerator, plus all these costs, it's just economically not viable. That's why there are something like 62 biomass incinerators in California. All of them are closed with the exception of 2. There's a couple in Colorado, they're closed. So it's really difficult, to be able to run those, especially if you're doing wildfire mitigation, because of course, the idea is to keep the vegetation down so it doesn't grow back up again. But once you've done the clearing, then as you know, the growth is fairly slow after that. So, now you've got to move. And that's one of the beauties of our machine. You can pack it up and move it to another site. So today, the system basically looks like this, the 3 pieces I was mentioning. And it plugs into the grid, and it's pretty simple. It plugs in the grid with, if you're familiar with net metering, it's the same way you do your solar or you do, any kind of alternative energy that you're interested. It's just a simple meter that the power company comes and puts in. Although they're difficult to work with because that's what they do for a living, is they make power. Like I said, then if you're able to, if you're a landfill, cities or towns, or I understand some states on the transfer stations will also provide the landfill diversion credits as well. The system arrives on 3 trucks. There's the 3 pieces I described. The only piece that really needs to be assembled is the cooling module. There's, you can see in the top left photo, those, we call them the sawhorses. Little green sawhorses have to be set up underneath it, and the system, put on top of it. And when you're done, you get something that looks about like this. Now, that's a fairly large cooler. The cooler depends on where you live. If you are in, let's say, Oregon or Washington, someplace like that, the cooler would be about half that size. This is the desert. And the key to maximum power is what's called maximum delta temperature, or delta T. And so, sometimes the water and things are better if you have those. If not, the cooler has to get slightly larger. So 12 years ago, this is where I started with this thing. I said, well, what's coming in the forest? Well, first, we've got battery-operated equipment, sure enough. And we've got other operations in the forest. We can make lumber. We can do all kinds of things. Unfortunately, we're about 12 years ahead of time. So, but the time is now, fortunately. We have shipped the first system. Oh, sorry. So, electric forest, biomass energy in the forest, reducing fuel consumption and reducing emissions. And this is the big deal, is to support battery-operated equipment. The first question anybody asks if you're going to buy an excavator or a loader or any one of these machines is, where am I going to charge it? Of course, if you're out in the middle of the forest. There are some people that have some schemes where they're going to charge some battery packs, put it on a trailer, drag it up to the middle of the forest, and charge your excavator. It works, but you've got the whole transportation thing. And then, as you may know, there's a difference in energy. There's black energy, gray energy, and green energy. Green energy comes from things like biomass and wind and solar. Black energy comes from coal, and gray is something in between. So you really are kind of defeating the purpose of going to battery operated unless you're using green energy. And so that actually is the purpose of our machine. So with the power generating firebox, with the design for the electric forest, then the power module here has batteries in it, and the unit would be operated all day long, and the energy goes into the batteries, and they're stored, and there's no grid connection. Again, fully portable. And then in the evening, you bring around your battery operated equipment, you plug it in, and you download that energy into the machines. Now, we're putting in the first system in Southern California as we speak. The advantage of something like this is now, of course, you've generated the electricity from your waste stream, so it's all green energy. and you can support, battery-operated equipment, which is having trouble with this gizmo here. So we're delivering the first system right now into Southern California, and the one component we're sort of, I don't want to say missing, but that's difficult is the batteries themselves. The batteries are really not hard. They're a lithium ion. Everybody's doing it these days. But what is a little bit challenging is the control circuit from getting out of the power module and into the batteries. And so that slowed us up a little bit. So we've delivered the first system, and we're hoping here within the next couple of months that we'll have the battery packs in there, so they'll probably be separate initially. So there actually end up being 4 components out there on the site. But by mid next year, we should be able to sell the system complete with one of the battery manufacturers. So you've probably heard the inwards mobile processing from Dr. Hahn and others. This was where we kind of ended up meeting each other. I wrote this paper I sent on electric forest, and this was the concept. At the time, I was thinking that we would build fairly large, maybe a megawatt worth of power, and you'd surround it with sort of a racetrack, and then you would have various kinds of processing, like we've been talking here, and you could support that processing in woods. Or our other market is land clearing. Big land clearing projects, there's no reason you can't have this same kind of system on a big land clearing project too. So we are also working with a couple of kiln manufacturers. So, this is another option for possibly a landing site. You could take some of the logs, horizontal bandsaw, and it would be possible to be able to come out of the forest with kiln dried lumber. So I mentioned we have a megawatt of thermal energy, and megawatt of thermal energy will dry some boards, that's for sure. So you can run the electric bandsaw, and you could dry the boards, and you could come out with a finished project. So we're working for a customer for one of these systems right now. We just got some more work to do on the kiln, but we're pretty close. So hopefully we'll have one of that's coming out west here as well. So hopefully we'll have that system in place next year. So where are we headed? Well, we being air burners. First of all, we got to get the electric forest type unit installed, which we're doing. Then we're going to look at increased battery storage, because the manufacturers of the battery operator machinery are changing. I won't bore you with those details right now, but they are changing the power, and they're changing the consumptions and some of that. So we'll probably need a little more storage. On the note of the biochar, you saw that burn boss in there. So the CRADA partnership we have with the Forest Service right now, what we're doing is we're building a machine, and if you're interested, you can go to our website, airburners.com, and you can see a video on it. And the idea is that you put the wood waste in, and it comes out quenched biochar at the back end, and off you go with your biochar. We started on that project with the Forest Service, to stick with that for half a second, because we have a lot of our customers who got on this before we knew anything about it. We have one customer I was mentioning at our table in Tampa, and he is manually pulling out the biochar. So he burns waste all day long, and then he gets an ash rake, and he pulls out the biochar, and he puts it in his own little sizing unit, because there's particular sizes that sell. And he has a broker, and the broker will say, yeah, I can sell it. Most of the time, the broker can move this stuff, and he's getting $125 a cubic yard right now. And so with our machine, he can make anywhere between $500 to $1,000 a day on the biochar. And I don't know whether it's 80%, he can always sell it or not, but the other beauty of the biochar is it'll store really well. And so you can hang on to the biochar for a bit, and he just won't make it if you can't move it. But it turns out it's pretty easy to sell. You find a biochar broker, they send you one of those heavy sacks, and you fill it up and call a truck, and off it goes, So a pretty simple thing. So we're trying to automate that now, but our machines already make biochar. And then I've got here hydrogen production. I'm hoping, and this is one of the things I'm working on personally right now, is the with the PG Firebox that, I don't know if you're familiar, but somewhere around 50 horsepower is probably going to be the breaking point between batteries and hydrogen. So 50 horsepower and below probably can be battery powered. 51 horsepower and above will be too big for batteries, so it will probably have to be hydrogen. Hydrogen because hydrogen is really clean. Hydrogen because it's moderately easy to make. Hydrogen also because it's real simple to convert a diesel engine, because you can convert a diesel engine simply to natural gas with a quick natural gas kit. It's the same thing for hydrogen. So we're hoping that that's our next evolution. And then last but hopefully not least, bigger systems. So our current system is 100 kilowatts with the battery storage, and then we're looking at a 1 megawatt system. We certainly have the heat energy, that's not a problem. But the difficulty right now is the organic Rankine cycle generator. The people that make them, their order books are full of electric companies buying 10, 15, and 20 megawatt ORCs, and so they don't want to hear from us at 1 megawatt. So they're quoting us like 3-year lead times and things like that. So, but sooner or later, we have people now supplying us that make 100 kilowatt and they make 250 kilowatt, and so we could put 4 of those together. But this is the size you probably need to do the in-forest. You need because you're going to consume it immediately. You may store some, but you'll also consume it immediately. So we probably have to get close to a megawatt. Like I said, we got plenty of power to do it. Just getting the ORC right. So, and that's about all I know. I click this thing, but it doesn't like me too much. Thanks.
Well, thanks, Brian, for that presentation. That's quite a bit of work you're doing there, and yeah, good luck on the hydrogen conversion. Okay, thanks, Brian. Now, last up, and definitely not least, we have one of our grad students from Northern Arizona University. He'll be giving, his name is Heesol Chang, and he's going to be giving us a presentation on meta-analysis on thinning costs of forest restoration, fuel reduction in the U.S. West. Like I said, Heesol is currently an MS student at Northern Arizona University, and he recently graduated from Kangwon National University with a bachelor's degree in forestry. And he worked as a forester for a year in Korea, moved to Arizona in 2019 to study forestry in the U.S., and he's currently studying the costs of forest thinning operations across the U.S., western U.S. And his objective with this data is to be able to focus on machine feasibility, and also to produce a model which will allow managers to be able to predict stump to truck thinning operation costs all across the western U.S. So with that, please make welcome Heesol Chang.
Thank you, Rich. Hello, everyone. I'm going to introduce my thesis project at NAU, and which is the systematic review to understand the cost of the forest thinning operation across the western United States. As you all know, the wildfire is a big issue in the western United States. So thinning operation is often used to reduce the wildfire danger and improve the forest health. But people questioned on the economic feasibility of the forest thinning operation because it mainly harvests the small diameter tree which has low value and it is very expensive. So, and forest managers are interested in reducing the cost of the forest thinning operation, and it is started with the better understand the cost of the forest thinning operation. But I read many studies, in the case studies, but there is good studies that synthesize the cost of the forest thinning operation across the western United States. So from the literature review, I organized the 3 harvesting methods that is commonly used in the forest thinning operation, and that is full tree harvesting method and tree length and cut length harvesting method. And there is 4 phases in the cost harvesting method, which is felling, extraction, and processing and loading. In the whole tree harvesting system, feller buncher and skidder and loader processor is commonly used for to produce the saw logs, and in case producing the biomass, the chipper and grinder were used. In tree length, chainsaw and cable ladder is commonly used in the tree length harvesting method, and typically these 2 machines were used in steep slope ground site. And in the cut length harvesting method, I want to point out that harvester, fodder, and loader is all of the machines in cut length harvesting method, and there is no processor because harvester does the both of the felling and processing activities. So in this study, the cost of the felling, extraction, processing, and loading were covered, and some of these cost is the stump to truck cost, and which will be expressed by the dollar per ton, dollar per acre, and dollar per cubic feet. So my study has 3 objectives. One is understanding the cost of the forest thinning operation in the western United States, and second is through the systematic review, summarize the thinning cost of each machine and productivity of the machines, and evaluate the key variable that affect the machine's cost and productivity. And final objective is develop a spreadsheet-based model that estimate the stump to truck cost of the forest thinning operation. So I'm going to talk about the study method. Before searching the literature papers, I need to set the criteria to select a paper. So I used selection criteria, 3 selection criteria. That is, study should be related to mechanical forest thinning operation and published over the last 40 years from 1980 to 2020. And it is conducted in the western United States. And I expected the data from these papers, which include the thinning cost of the forest thinning operation and machines productivity and variables that impact the forest thinning cost. It is my literature searching process, and I used 5 database searching engines, which is Web of Science, Biosys, Cap Abstract, and Greenfire, and A&E Science database. And I found 1,336 papers to review the title and abstract, and then I reviewed the full text 185 papers. And additionally, I add 9 more papers through the citation tracking and reference checking. So I finally got the 21 papers for the data extraction and analysis. So I'm going to share my result that I found. Here is 21 list of the paper that I found through the process that I in previous slide, and I got 51 sealing operation cases from these 21 papers, and most of them were whole tree and cut length harvesting method, and also most of them were conducted in mixed conifer forests. Before explaining the key variable, I need to say why it is important. The key variable, I gathered the predictor variable from the papers, and it is directly impact the machine's productivity. And machine's productivity impact the machine's cost, hourly cost. So finally, these variables impact the sealing cost, and so the key variable in felling machines, DBH was the key variable in chainsaw to predict the productivity. And travel distance and number of trees per cycle were key variable for the fellow buncher, and DBH, travel distance, and number of logs per cycle were key variable for harvester that is commonly used in the cut length harvesting method. In the extraction machines, the travel distance and yarding distance were key variable in common, and number of trees per cycle was an additional key variable for the skidder. In processor, number of cuts per tree and DBH were the key variable, and it is very similar with the harvester's key variable because harvester conducts the processing activities, and the number of logs per cycle was the key variable in the loader. And I collect and calculate the mean value of the production rate and the sealing cost of each machine that used commonly in the forest sealing operation. And I want to point out that fellow buncher production rate was almost 40 tons per PMH, and it is almost double of the harvesters. And we should remember that harvester conduct the both of activity, that is the felling and processing. And loader and processor shows the higher production rate rather than entire machines, and especially loader in tree length and whole tree harvesting method shows the very high production rate. And in sealing cost of each machines, I'd like to point out that the harvester is most expensive and fellow buncher is most cheapest one for the sealing cost. And in here, you can notice that cable yarder had extremely high sealing cost, which is $28.87 per ton. And other processor and loader shows the lower sealing cost. And the dollar per CCF, which is 100 cubic feet, is similar pattern with the dollar per tons, such as fellow buncher is cheapest one and harvester is expensive one in the felling machines, and cable yarder is extremely expensive in among the entire machines sealing cost. So I use these data to calculate the cost of the harvesting system that is commonly used in harvesting sealing operation. So most efficient harvesting system is fellow buncher, skidder, processor loader in the full tree harvesting method, which the result was the $18.39 per green ton and $40.9 per 100 cubic feet and $814 per acre. And one another commonly used harvesting system was cotton length harvesting method and harvester fodder loader. That is the $25.04 per green ton and $59.7 per CCF, and $1,138 per acre. And you can notice that the cost of harvesting system including yarder was very higher than other harvesting system because yarder, I mentioned the yarder is typically conducted in the steep slope ground site, so it is very expensive than other harvesting system. So this graph shows the proportion of each cost of a pace. So here, I want to point out that the extraction cost is the biggest portion in the whole tree and tree length. And it is also similar proportion in the cut length, but the felling cost is the biggest one in the cut length because harvester is used in the cut length harvesting method, and it includes the felling and processing activities. So finally, I briefly explain how my model works to estimate the stump-to-truck cost. So the user will input the standard variables and operation variables and user selection. And these variables will be used to calculate the productivity of each machine and finally impact the forest thinning cost. I want to point out that the key variables that I mentioned was the big role in this calculation in the model. Thank you, everyone.
All right, great. Thanks. Appreciate it, Heesol. Good presentation. I've got to see some of his work up front. He's really putting a lot of work into this. Some of his spreadsheets are just amazing. And just so everyone knows, Heesol's going to be defending his thesis in what, 3 weeks? Is it 2 weeks? And so hopefully everybody will get a chance to wish him good luck. I think you're going to do fine. Good job. At this point, I think we'll just open it up. We've got our questions. I think are we too far ahead of time here? Or?
Got 2 on Q&A.
Okay, so I guess we'll start with the Q&A on the online Q&A.
Yeah, so the first question was for Matt and Preston, and that's it's kind of a two-parter. It's who was the landowner of the timber sale, and was this a service contract or a timber sale?
So the U.S. Forest Service is the landowner, and it was a service contract. That is correct.
Okay, and then part 2, what was the estimated dollar per acre if this was a service contract?
It varied depending on where we were at, what we were doing, because there's actually more than one contract there.
Okay, thanks, Matt.
Yep.
The next question I have in the Q&A is for Brian. When using the in-woods generators to recharge equipment, could you burn fresh green slash, or does it need to cure first?
No, we don't have to cure anything for our machines. You can cut it and put it in there. So green's fine. Got it?
So that's all online.
So do we have any other questions in the audience here? Oh,
Yeah, I wanted to ask Brian, as a entrepreneurial scientist and inventor, having the experiences that you've had and the challenges you've had bringing this product forward, what do you see is needed to accelerate the speed that we now have to go to, have to utilize to go from new inventions to, to being put into use? And, you can either speak to I'd like you to speak to the challenges and what you see we need to be doing.
Sure, it's a good question, actually. I think the biggest problem that we all face is regulations. When you have an idea, it's very hard to get these passed. Like for our company, we burn things. And so immediately, the very first time I went to the EPA, I got invited to go to Raleigh-Durham, which is their headquarters. And I walked in for this meeting, and it was a big deal to get a meeting there because they don't let people in this place. And the girl at the front desk, as I signed in, the lady there, she says, "Oh, you're the incinerator guy." She says, "Do you want some holy water?" And I said, "Oh man, is it going to be one of these?" So, and that was 20 years ago. And so it's hard to get the rules changed. We were just talking about with Nick, with Arizona. The whole valley, Phoenix Valley, was cleared. Not that I wanted it to be cleared, but was cleared with our equipment. There must have been 50 of our machines in the valley getting rid of cotton and orange trees and grapefruit trees and all this to build homes. And today, if you try to get a permit for our machine in Arizona, they say, no, that's a bad thing. But, it did a great job of keeping particulate matter out of the valley. And so it's kind of hard. I have a team right now at CARB, California Air Resource Board. Well, they're actually there tomorrow. And, they've just recently come around to, after we've been in California for 20 years, and we probably have close to 200 machines in California. The state owns probably 50 or 60 of our machines. And so California Resource Board says, "Hey, can you come and explain these to us? We want to try to understand these and see if we, geez, all right. Okay, so, in San Joaquin Valley, we're considered the best available control technology. And, so it's regulation. It's so hard to bring these things through. It's like the battery-operated equipment, right? Talk to the companies that are building battery-operated equipment to get it out there. It's really hard. First of all, it takes a lot of money. It's only the Caterpillars and the John Deeres that can do this kind of stuff. And then once they get it out there, we have to have, I mentioned green and gray and black, electricity, energy. And so now there's regulations popping up saying you can't use, in the forest, you can't use your battery-powered excavator unless you can guarantee it's green energy. Wow. Damn, are you kidding me here? At least we're making one step. How about let us do that, and we'll figure out the whole green energy thing, next. But it's hard. So I'd say regulations is the most challenging.
we got another one over middle of the room there.
It's another question for Brian. I think we've got 2 WUI subdivisions in our county now that have air curtain burners. I don't know if they're yours or not, but just hypothetically, in a situation like this where they are doing a lot of their own thinning and fuels reduction, so they're using the burner periodically, is it your experience with like a tieback net meter, is that an acceptable thing to do where maybe this subdivision is only using it a few weeks out of the year? Are you finding that from an electrical production standpoint, if they had your unit, is that viable?
Yeah, good question. The answer is no.
Okay.
You know, it's just, you know, you're gonna pay $865,000 for the machine, so the first thing you do is you look at your payback, right? And fortunately for our machine, you've got two paybacks. You're eliminating waste, so what's that cost to get rid of in your area? $15 a ton, in Australia, it's $280 a ton. So they're really easy to sell our machines down there, you know, but if you're only at $15 a ton, that's still a good number. And then the electricity, we don't compete against electrical rates, we compete against diesel fuel. So that's helpful, you know, because it's $3 or $4 a gallon. But it's still, if you're gonna use it, you know, sparingly, like once a month, twice a month, or 1 week a month, then it's probably not the best option. So not a bad option, though. I mean, I'll sell it to you, but you know, it's probably not the best option going.
Thank you.
Any more questions from our audience? Is there any more online questions? Okay. Oh, we got another one.
So this question is from Miller Timber. For the project in Colorado, I was curious about the different strips that you're cutting into landscape. Is your harvester able to sort of turn and get more material and logs between the strips, or is it primarily just single strips?
So those pictures that showed the strips, the reason why you see the strips there is that's the corridors that the machines travel down. They actually reach 32 feet from the center line of each machine and thin the trees amongst it. So the trees that are left are the green trees that were still on site. The goal was to try to retain as much green that was still there on the hillside, not to remove everything on the hillside. So where the corridors were at is where the machines traveled, and then they reached and took all the dead out from between. So what's gonna happen, and what is happening already, is there's a lot of understory that was already starting to reestablish in that stand, and a lot of regen, so protecting that regeneration was pretty key to that whole project. And now it's gonna start filling back in, and they're visible for a little while, and then they're gonna start fading out, and then as those crowns fill in, that kind of goes away. But the removal was so high in that stand, 80% plus percent of the trees in that stand were dead. It makes it kind of stand out a little bit.
Okay, great, thank you.
Yeah.
Michael.
Did what you showed at the end, do you have the either the spreadsheet or the tool that you talked about earlier that you want all this to be housed in so that folks can use it as an accessible tool? How far along in that process are you?
I made the model in the Excel spreadsheet based, so there's not open yet, but I don't know. Future, yeah.
Yeah, well, that was actually my next question of you. You're probably just, you know, looking at getting the project done, but it sounds like you've started to think about how you're going to make this known, you know, from the folks that could actually use it. So that's, I guess, the next step, right? Yeah. All right, great.
Michael, I just want to give you a little more heads up on that. So Heesol is working with me as a master student at NAU. So the Heesol and me are trying to develop a spreadsheet-based model so that the users can just enter input values of those stand variable, operational variable, or that. And he has found the very silicon, I don't remember exactly how many, the regression equation that can be used to estimate productivity, many different harvesting machines that commonly used for mechanical thinning operations. That's what he found. So we are going to be able to use those equations to estimate the thinning productivity. We already know the hourly machine cost. So we have hourly cost machine, and they have hourly thinning productivity. We are going to be able to estimate relatively, very accurately the thinning cost from stump to the truck. So that is our goal. Now, I just wanted to share with you some of the things what I learned through the Heesol. There were some the thinning cost analysis model being developed in the past. However, each model is not perfect. I'm not saying the model we are going to develop is perfect. That's not what I'm saying. But I think we can continue improve that effort of developing the cost, model of estimating the thinning cost. One of the things what Heesol and I are trying to do is we actually collect the cost of the thinning productivity based on strictly thinning study. We are not going to use any machine productivity equation that was developed based on the thinning clear-cut operation, because that's a totally different story. So we try to limit our thinning productivity equation only for thinning operations. So that's one of the things we're trying to do to improve the performance of the model is being developed over time. That's the one thing we're trying to do. So I think he's going to initially develop the model from his master thesis project. And then he and I are going to continue putting more effort to update that information, the model, as we develop. As we get the more information to add to and upgrade the costing model. So it's going to be ongoing effort to develop the good final costing model. I just want to congratulate the Heesol. He put a lot of time to practice of his presentation, and I can tell you that. Yeah, I've been working on with him until almost midnight last night to make sure he doesn't screw up. So great job, Heesol. Good presentation. You made it. Without things screw up. That's good.
Great, yeah, thanks, Han, for that, detailing that. That's, something else I'll point out comes out of those the production studies, and being a former engineer. Oh, geez, I shouldn't have said that. Lauren, my major professor, would kill me, because he always said, once an engineer, always an engineer. But a lot of that stuff you can pull out of those studies is just, some of the, like the scheduled, machine hours, production per scheduled machine hour. Some of that stuff is very important. Engineers use that kind of stuff a lot for, that kind of, for production estimates. And so it's going to be a very useful study, I think. But anyway, I think we're right at break. Wow. I think that was a great panel, and I'd like, if you could, give them all a round of applause.
Thank you, Ed. That was a great panel, as you said. So I think, as Rich said, we are right on. We are right on our schedule. So we are going to be able to take a 20-minute break. Congratulations. So we are going to take a 20-minute break, and we are going to get back to the table by 2:40. So enjoy 20-minute break, stretch after the lunch, and see you in 20 minutes. Thank you.